Hello, everyone. Last time we were talking about we talked about science and the scientific method. We talked about the Earth and the sun. And today what we're going to talk about is the sun and everything else which goes around it. And that has a name. And the name is the solar system. The solar system. The solar system is the system of the sun. Sol was the Roman sun god. So Sol means sun. So it's the system of the sun, or if you prefer, the sun and the bodies which orbit it. So a couple ways to define the solar system there. The system of the sun, or the sun and the bodies which orbit it. And we did talk about last time, at least one thing that went around it. So let's talk about the members of the solar system. The solar system members. Members of the solar system. And we're going to start with number one. Let's start with the biggest thing in the solar system. The largest thing in the solar system, and that is, guess what it is? It's the sun. So number one, sun. What is the sun? Remember what the sun was? A star. So how many stars are there in the solar system? It's just the sun. So there is one star in the solar system. That's it. So one star in the solar system. What else is in the solar system? The things you probably think about, well, we talked about one last time. Number two, what else do we have? We have the planets, right? But we're going to distinguish between types of planets. We're going to call these the major planets. Major planets. And we now have eight of them. That's eight. One has been demoted, which you may have heard about. So what is a major planet? We're going to go over the major planets in order. The major planets are relatively large, spherical. That's what makes it a major planet. Bodies orbiting a star. So it's good to write down the major planets, these relatively large spherical bodies orbiting a star. And let's take a look at them. I'd like you to remember the order of the planets. Even though this class is not a solar system class, I still want you to know what the solar system is. I want you to know the order of the planets, the major planets. And again, these are the spherical bodies orbiting a star. Spherical. Now, let's take a look at these planets and how to remember them. So let's take a look. Well, first of all, let's show the one star. Let's show the sun. So sun. All right, there's the star. We're shrinking everything down in size. And let's talk about the closest planet to the sun. And I'm just going to write it up here. What is it? Closest major planet? Mercury. Mercury is number one. What's the second closest planet? The second planet out. And we're just looking at the orbits of these planets. That would be Venus. And you know what the third one is. We'll make this in blue. The third one is the one we are on. The third one is Earth. Then the next one, I'll just show part of its orbit here because I'm kind of running out of space. So number 4, Mars. And then, let me put one over here. Here would be kind of part of its orbit. Number 5, Jupiter. Jupiter, let me write that so you can see that. ER. And then we have part of its orbit there, should be going all the way around. Number 6, Saturn. And then we have Uranus. The scale's all off here. 7, Uranus. That's a U. And then finally now we have Neptune. So they're the planets, the order. And I'm going to put something over a little bit farther here, right at the edge, like right at the edge here. There would be something there. And it used to be a major planet, but it's not anymore. I'm going to actually make a line here, kind of like there. And I'm going to put it in a different color here, just to show you it's not a major planet. It used to be, we used to have Pluto. It's still there, but it's not called a major planet anymore. Now, I want to tell you a mnemonic device, a way to remember the order of something by thinking of a sentence to help you remember the order of the planets. And this is one my dad taught me when I was 5 years old, about 5. He said this, remember this, and you can remember the order of the planets. So he proceeded to say this, thinking of the first letter of each of the major planets, he said, Mary's violet eyes make John stay up nights panting. Mary's violet eyes make John stay up nights panting. And I remembered it. That's the one I originally remembered. But now, without Pluto being a major planet, you don't have Pluto. So it still works. Look, Mary's violet eyes make John stay up nights. Mary's violet, it works. So that works. I also heard another one. Somebody once said this to me, and there's been different variations of this. My very educated mother just served us 9 pizzas. Wow, that sounds pretty good. My very educated mother just served us 9 pizzas. But without Pluto, it's been changed, but still works. My very educated mother just served us nachos. Sometimes you want pizza, sometimes you want nachos. Still works. But the best one I'd ever heard, of all time, was this when we had Pluto. My very easy method just sums up 9 planets. Oh man, is there a better mnemonic device in the history of mnemonic devices? No, it makes sense. It just goes so well together. But without Pluto, you know what it has become? My very easy method just sums up nothing. It doesn't work. It doesn't work. It's terrible. That's one. I mean, I kind of don't like having Pluto being demoted to, well, we'll talk about that. But the main reason I don't like it is it messes up the mnemonic device. So, I mean, one guy once told me this one. I once said, hey, think of a mnemonic device for this when we had Pluto at the time. This was years ago. And he said this. He said, I got one for you. And I think, okay, yeah, what is it? Tell me. He said, my van's engine miraculously jump-started Ursula's neon Pontiac. And I thought to myself, I said to him, hey, man, that's a great one. But I thought to myself, no one's ever going to remember that. But I remembered it. So it was a good one. But now, without the Pontiac, no more Pluto. My van's engine miraculously jump-started Ursula's Nissan. It still works. The only one that doesn't work is the best one ever. So there are the planets, the major planets. And let's take a look at just some pictures of them. And we'll share screen here. And look at this. You remember this picture from last time? There's the Earth, the Sun, the Earth. And let's take a look at some of these other major planets. Well, this is not to scale. This is not to scale at all. You probably can tell that. This shows the sun, the one star. It's not a major, it's a star, not a major planet. But here's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. We have a better picture of Pluto now. And I think they're showing Pluto way too big here, way too big. And so look at, these are actually pictures of the planets. These are not where they are in orbit, and their sizes are not accurate. So at least they're real pictures of the planets. And you could see, I mean, let me show you a better representation of the sizes. This shows the planets in line. They'll never get totally in line. There are people that have worried, like in 2012, when the world was supposed to end. Remember, the world was supposed to end in 2012? And remember, it didn't end in 2012? You remember it didn't end. Well, one of the reasons they said the world was supposed to end was the planets were going to line up. Well, the planets don't ever line up. And even if they did, it wouldn't make a difference. So planets lining up is not a problem. So this is just an alignment just to show the sizes. And look at the inner planets here. Mercury, Venus, Earth, and Mars, small. Look at Jupiter, Saturn, big. I mean, Jupiter, over 1,300 Earths could fit inside of it. It's over 11 Earths across. Jupiter and Saturn, Uranus and Neptune are the gas giants, no solid surfaces. And look, shows you the size of Pluto. And look, you can actually see the name here, which I kind of held back, but I might as well show you now since you're seeing it. Dwarf planet. Pluto is called a dwarf planet. As is this Ceres, which used to be the biggest asteroid, but no, it was promoted when Pluto was demoted. There's this thing that we discovered, and these are not where they are in reality, but this thing is a little bit bigger than Pluto. And they used to call it Xena, but they call it Eris now. And here's the numeric designation when they discovered it. That's what doomed Pluto, and we'll talk about that. We will talk about that. So there are the planets, and yeah, take a look here. Here are the planets showing, well, you've heard about the flat Earth, right? You couldn't help hearing about it. Remember Kyrie Irving, what a couple years ago came out, a basketball player, great basketball player, said the Earth was flat, and then Draymond Green kind of agreed with him. And I'm a big Draymond Green fan. I think Draymond Green wouldn't have said that. I think he's kind of sticking up for a friend of his. But yeah, and then there was this fervor over it, and then Neil deGrasse Tyson stepped in. I got to show you what Neil said. I love Neil deGrasse Tyson, talking about Kyrie Irving saying the Earth's flat, and it turns out a lot of these people were saying that, and then boy, if there's a flat Earth, don't even get me started. There are problems with a flat Earth, especially if everything else is everything else spherical. If the Earth's flat, is everything else flat, or is everything else not real? I mean, there's some weird stuff going around. We'll talk. I better not start because I don't stop. But yeah, flat Earth. And some people say Antarctica is all around, like Antarctica is filled with mountains and you can't get past the edge of the Earth. I mean, how could the Earth be flat? I mean, have you ever dug a hole? If the Earth were totally flat, you can't dig a hole without getting to the other side. So I guess the Earth is not totally flat, what they say. But if you ask them, I don't know if they have an answer. And if it's flat, what's on the other side? And there are problems. You even can see the Earth being spherical. You can actually see the curvature of the Earth if you're high up in a plane. And some people say, no, they do that to the windows in the plane to make it look that way. They do it to the windows, but from the time you take off to the time you're up at 35,000 feet, I never see anybody working on every window. I mean, that's ridiculous. So how come windows don't have that when you're on the ground? So yeah, it's so ridiculous. I'm started. I've started. I said I wasn't going to start, and I'm started. So I'm going to stop. Let's see something else here. Here's some pictures of the planets, real pictures showing Jupiter and Saturn being, I mean, the sizes they are. And so these are real sizes. They're lined up. They don't really line up like this. Not going to happen. Never does. And again, if it did, nothing would happen. Now, there are people that really got upset when Pluto was demoted to a dwarf planet. And it says, look at this billboard. I'm not even sure where this is, but it says, start calling Pluto an asteroid, and it starts acting like one. Well, so this shows the Earth, and this represents Pluto slamming to the Earth. I don't know. We're not calling it an asteroid. We're calling it a dwarf planet, which is different. But again, even if we call it an asteroid, does that mean that asteroids misbehave? I mean, asteroids, I mean, sometimes I guess they hit Earth, but not this big. So I don't think just because if we called Pluto an asteroid, it would head billions of miles straight towards Earth and slam into it. I don't think Pluto does that. But there are people that are upset. And you can see, look at it. It says paid for by the friends of Pluto. Pluto has friends. Actually, in New Mexico, there are a lot of friends. I mean, other places too. In New Mexico, they voted to make Pluto back a major planet. And I think it actually passed. So if you go to New Mexico, Pluto is a major planet. Not that Pluto is in New Mexico. It's not. It's still where it is. It's in its orbit. It hasn't left or anything. But New Mexico, I guess New Mexico can't really do that. States can't decide astronomy things. That's the International Astronomical Union. They decide astronomy things. So even if a state votes on it, it doesn't count. I mean, you could vote on anything you want, and then with a group of friends and say, we're going to call something this. Yeah, with your group of friends, it doesn't mean it's official. So I still think Pluto should be a major planet, but it's been changed, and unfortunately. So now, what else am I going to say about that? Oh, take a look at this. Take a look at that. Let's talk about something else on our list. And to do that, let's go back. What is this thing? This thing, another member of the solar system, that is Moon. So let's stop share here. Let's go back to this list. And let's, we already had the sun, the major planets, and let's erase this. Let's put number 3. So I'm just going to, just for some space, I'm going to put number 3 down. So number 3 on our list. What was that thing? That thing was the moon. But the moon is called a natural satellite. Natural satellites. And some people call them moons. I don't call them moons, and I'll tell you why. And natural satellites, there are 150, probably, well, actually, you know what? A lot more than 150. There are probably about 200, approximately 200 in the solar system, about 200. So about 200, maybe a little bit less, but about 200 in the solar system. And what are they? These are bodies which orbit what? Planets. So they're satellites. They're satellites, natural ones that they're there. Anyway, without us, there are artificial satellites that we put up that orbit the Earth, like just a bunch of like weather satellites and like GPS satellites, so you can use Waze and things like that. There are a bunch of satellites. There are like 7,000 satellites orbiting the Earth. Those are that we put up. Those are called artificial satellites. If it's naturally there, like Moon, the moon, that's called a natural satellite. And I don't call them moons. I mean, everybody else does. Everybody else, even in books, they call them moons. But here's why I don't like to. Moon is the name of our natural satellite. So we go out there, and when you see another planet in the sky, like Venus or Jupiter, do you say, oh, look at that Earth. That's a beautiful Earth. And look at that Earth over there. That's another beautiful Earth. No, you call them by their names. So why call all these other satellites by the name of ours, which is Moon? And why not call them their names? Because they have names. I mean, they have their own names. So why call them moons? It doesn't make sense. It's like calling the other planets Earths. I mean, there could be planets out there in some other system, like Earth, but you don't call those Earths. Earth's the name of our planet. So this is just a pet peeve of mine. I mean, if you don't really want to listen to me on this, you're fine. Everybody else probably agrees with you, but it bothers me. So I have to say something about it. I don't like to call them moons. I call them satellites. But if you go out and you're showing people things in a telescope, I found out going to schools, and say, hey, look at the satellites of Jupiter. You can see them in there. And people say, what are you talking about? Those are moons. And okay, all right, you win, I lose. So, but I got to tell you, I had to tell you this. So that's number 3. Now, what else is there? I mean, Jupiter, satellites, just to say, Jupiter and Saturn have almost 90 of them. So there it is. There's why there's close to 200. We have one natural satellite. All right, so now let's share here. Let's go back to our picture of the moon. So there's our satellite, Moon, Luna. Oh, look at this. That on our list. On our list is number 4. What is this thing? It's not a major planet because it's not spherical. But there are other types of planets besides major planets and dwarf planets. There are minor planets. Minor planets. And so this is one, and I'll come back to this. This is a minor planet called Ida. And this is found out it had a satellite. And it's not really spherical here, but Ida's about 40 miles this way and about 20 miles this way. So it's not a major planet. It's a minor planet. Like an asteroid, minor planet, asteroid, same thing. So Ida had a little, we found out this is going around Ida, this little thing. So Ida had a satellite. So then they had to name it. This is Ida. Then somebody said, if this Ida, let's call that Ho. Idaho. No, that didn't happen, luckily. Did not happen. So let's take a look here. Let's put it on our list. So we have the minor planets. and also called asteroids or meteoroids. Meteoroids. All right, same thing. An asteroid is a minor planet. A meteoroid is just a smaller asteroid. So minor planets, and there are, I got to tell you right now, there are probably millions of these things. They get down to the size of a grain of sand. Millions of these minor planets, millions. And these are smaller, non-spherical bodies, usually made of rock or metal, orbiting a star. Those are the minor planets. The minor planets. It's good to know that. So these are non-spherical. Well, major planets are spherical, are ball-shaped, and these are. And why do you think these are non-spherical? Non-spherical. How come they're not the shape of a sphere? Because there's not enough gravity to hold it. Yeah, there's not enough mass, so there's not enough gravity to pull it into a sphere. That's why. Now, there's something I do need to mention to you. So we have this down here, number 3 and number 4. So hopefully you have those down. I'm going to erase them. But take a look at this before we do this. And the satellites, we have, I mean, those are small. We have about 200 of these. Minor planets, they're even smaller than the natural satellites. They're even the size of a grain of sand. Look, there were millions. Remember we said there was one star, the sun, and there were 8 major planets. What do you notice about this? Do you see there's a trend here? We're getting from smaller number to larger. But what about the sizes? What about the sizes? Yeah, the sizes. Here's what's the case. And this is there's something where you can see this. If you have smaller bodies, there are going to be more of them. And if you have larger bodies, there are not going to be as many. Kind of like there's one star, the sun, and then the planets are second biggest in the solar system. So there are only 8 major planets, more or less. And then the minor planets are really small. So there are going to be millions of these things. Well, you notice this with potato chips? Aren't there a lot of potato chips? Well, if you open a bag of chips, there are hopefully a lot of chips, but the bigger chips are at the top, right? Bigger chips are more at the top. What's at the bottom? Crumbs. There are always more crumbs than bigger chips. Why? Because they're smaller. This rule is called something, and I'm going to hopefully get rid of that now. I got to write this down, what this is called. This is important. This rule, because it is seen very clearly with potato chips, is called the potato chip rule. Got to write that down. Potato chip rule. And what this says is there are not always, but usually more smaller bodies than larger bodies in a system, or let's say a region. I mean, it seems to work. It works in the solar system, but it also works on Earth. Are there more people or more ants? Remember, ants are smaller. I've heard there are a million ants for every person. I mean, I could imagine that, right? When you get infested with ants, you can see just in a small region how many ants there could be there. Are there more? So they're smaller. Ants are smaller, so there are more of them. What about elephants? Elephants are bigger than people. Are there more people or elephants? Aren't there more people than elephants? I mean, it doesn't help the elephants' cause because we destroy elephants. That's not good. But I think even if we didn't destroy elephants, there'd be more people than elephants. Elephants would be more rare. That's the potato chip rule. I like you to remember that because I might ask you about a couple things in the solar system. One smaller, one bigger. Yeah, I'd like you to know which one should be more. So that's the potato chip rule. So let's go back to these asteroids, minor planets, and I want to show you where they're found mostly. And it's kind of messy here, but I'm going to just do this anyway. Between Mars and Jupiter, look, there's the orbit of Mars. Here's the orbit of Jupiter, and I'm going to put a bunch in here. Orbiting around the sun, asteroids. We think most of them are found here. Well, if not most, a lot of them. It's like a belt. It's like thin. It's all pretty much, the solar system is on the same plane, the same line. So it's a belt of asteroids between Mars and Jupiter. Between Mars and Jupiter. Good to know. Between Mars and Jupiter, and it's called the asteroid belt between Mars and Jupiter, where millions of asteroids are. Up to some of them hundreds of miles across, and most of them probably the size of a grain of sand. A lot of dust there. We call them a little meteoroid if it's that small. So those are the minor planets, the asteroids, a lot of them between Mars and Jupiter. All right. Now, a couple more things. What are we doing? I'm going to share. Let's come back to the asteroids, minor planets, and we'll move on. Here's something that just happened. Actually, did you see Comet Neowise in the sky? This is a comet. This is not Neowise right here. This is Comet Hale-Bopp. So that's Comet Hale-Bopp. And what is a comet? Now, here's the comet. That's not the comet. That's a nebula in the distance, a cloud of hydrogen gas very far away. This is part of the solar system. There's a chunk of ice here, and these are tails, a gas tail and a dust tail. Comets are beautiful. One of the assistants for Astronomy 3, you might be having Joe or you might be having John for this class, but he is a great photographer, John. He has a great camera. That's why he's a great photographer. He has a great camera. I guess if you have a great camera, you become a great photographer. If you have a terrible camera, you're not such a great photographer. I mean, that may not be true, but with John, it's true. He has a great camera. And he takes some great shots. He didn't take this one, but he took a great shot of Neowise. I got to show you that. I will show you that at some point. Just beautiful. And I ordered some, just to put up, and it's beautiful. So we got to talk about what these comets are. What is a comet? A comet is different than an asteroid in one particular way, different than a minor planet. It's small, like a minor planet, most of them, but it's made of mostly ice. So let's take a look at this. So comet. So this on our list, what are we on? Number 5 in the solar system. For members of the solar system, number 5, comets. And comets are dirty ice balls orbiting a star. But in 2000, and I think it was 2006, it might have been 2006, we found a comet that was more dirt than ice. If it's more dirt than ice, you can't call it a dirty ice ball. You have to call it a icy dirt ball. But I'm not going to write that down because that's kind of a derogatory name for a comet, an icy dirt ball. No, don't call comets that. The comets are pretty neat. So we'll call them dirty ice balls orbiting a star. And they get down to the size of a little grain of ice. They could be that small. So they're probably billions or millions. We'll just say billions. Billions could be a lot of millions. Billions in the solar system. These comets, just beautiful. And I want to show you where these comets are found. These comets are found in a couple places. One place where they're found, remember there's Neptune. We didn't even show, here's Neptune. I'll put an N for Neptune there. The comets are orbiting around, a lot of them, just beyond Neptune's orbit. I mean, it's even over here. I'm not going to draw on this, but yeah, we don't even know how far this goes, but these all go around the sun, these comets. And the observatory that discovered this was the Kuiper Airborne Observatory, named after, I think it was Gerard Kuiper, not Dwayne Kuiper, but I think it was Gerard Kuiper. And we call this region of comets. It's kind of like a belt of comets where this is a belt of asteroids. It's called the Kuiper belt. And these are comets. Comets. Just beyond Neptune. We don't even know how far it goes, but there's millions of these things orbiting around, and we don't even see them unless they come close in. We can't detect them. I guess there are things that can detect them, but we don't see them with our eyes unless one of these comes in because they're staying out pretty far in orbit. But if they hit each other, they could kind of wander in and get close to the sun, and the sun's energy will cause the ice to sublimate, turn to gas, and then you see the tails. It's beautiful. And if you saw Neowise, got a good look at it, it was early morning for most of the time. It was just beautiful. It wasn't as good as Hale-Bopp. It wasn't as good as even Hyakutake from about just over 20 years ago. But there's another astronomer who figured out comets are not just coming from here. Actually, even before we realized there was this Kuiper belt, there was an astronomer that realized that comets come from all directions. They're not just on the same plane as the solar system, like on this flat plane, kind of like this board where pretty much everything is. comets come from all directions around the sun periodically. And we're seeing them from all directions at different angles. And they take a long time with their orbit to they get farther out than the Kuiper belt. So they're comets coming from a very far direction, in a very, almost like a cloud around the solar system. A cloud of comets very far out there because they come from different orientations and not just along the same plane here. And this astronomer was named Jean J.N. Oort. So what do you call a cloud of comets theorized by Oort? The Oort cloud. Is also comets, but it is far, way farther than the Kuiper belt. We don't even know how far it is. We even say a light year. We'll talk about it, like 6 trillion miles out there. It's just farther than the Kuiper belt. So the Oort cloud is far, and the Kuiper belt is just, well, Oort cloud is very far. The Kuiper belt is just far. So there's where comets come from. As far as we know, as far as in the solar system. And there was actually a comet that we came from another star system, orbiting another star. Actually, just it left its system and came into our system just over a year ago. So that's pretty interesting. Now, one more thing we have to mention. One more thing, and that is this. Let's share here. And look at this. It's a picture we got in 2015, a spacecraft we sent to this place that we hadn't been to, a spacecraft we sent to this place after it was demoted. This is Pluto. It's like a big chunk of ice. It's like a big comet, but spherical. I mean, it's ice. And Pluto, this is the best picture of Pluto we have. I mean, we have some other pictures that go along with this that this spacecraft called New Horizons took. New Horizons took 9 years to get there. And during the time it was traveling, during the first year, we demoted Pluto. So it headed off towards the 9th planet. And by the time it was a year away from the Earth, it wasn't going to the 9th major planet anymore. It was going to a dwarf planet. But I don't know, they kind of renamed this the spacecraft. That's okay. I mean, it's still there. Pluto's still there. It's just not called that. Now, let's talk about these dwarf planets. All right. So we'll talk about these dwarf planets. And to do that, well, let's take a look at our sheet here. So number 6, dwarf planets. Now here's the criteria. Let's talk about the criteria from dwarf planet. To be a dwarf planet, A, you must be spherical. Must have enough gravity to be spherical. All right, but the Earth's spherical and the Earth's not a dwarf planet, so there must be more. All right, you must orbit a star. Well, any type of planet orbits a star, right? These dwarf planets. The Earth orbits a star, so and the Earth's not a dwarf planet, so there must be more. There is. See, you must not be a satellite. Well, if you orbit a star, you're not a satellite. Satellites orbit around planets. And the Earth's not a satellite. So the Earth, if it were just A, B, and C, major planets, these criteria apply to major planets too. But take a look here. Here's what they got Pluto on. Do you know where Pluto is? Pluto is right in the midst, not the mist, the midst. I'm going to say it, midst. The mid, M-I-D-S-T, the midst. Oh boy. The midst. Right in the Kuiper belt. Pluto's in the Kuiper belt orbiting around with a bunch of other icy things, comets. Pluto's like a big comet. And here's what they said. Here's what got Pluto. D, you must not have cleared your orbit of other bodies, which means you're orbiting around with a bunch of other things near you. It means you don't have enough mass to have enough gravity to pull in stuff. Now, the other major planets, well, for the most part, there are some asteroids in their orbit. They've kind of cleared their orbit. They've taken in things that have become, like the Earth's taken in a bunch of stuff early in its formation, and Jupiter and Saturn, all these have pretty much cleared their orbit. But Pluto has not. Pluto has not taken in all these comets. I mean, so there's a bunch of other things orbiting with it. So they say if you You must not have cleared your orbit of other bodies. Means there's other things orbiting with you. And because of that, that's what demoted Pluto. And you may say, why do they have to do that? How come? I mean, why all of a sudden? Well, remember that little thing called 2003 UB, I forget the designation, Eris, Xena. We found something bigger than Pluto. So if we found something bigger than Pluto out there, it was going to be the 10th major planet. And then we started to find more of them. And we'd say, oh my God, we're going to have 11 major planets? Why were we finding more all of a sudden? Because we had better equipment, better telescopes, better technology. So we said, okay, we better cut our losses right now. We better, every time we find a thing out there spherical, let's not call it a major planet. And then we're going to have to remember all these are not just 9, but it could be hundreds of major planets. Let's just have a new designation, a dwarf planet. And then when we find something like Pluto out there, it's going to be called a dwarf planet. Then you don't really have to remember it, like the 8 other major planets. Well, I really think they should have grandfathered in Pluto, since it was, I mean, just so much history to Pluto. Look, we have Disney, Pluto at Disney, but you can't really change Pluto too much. Yeah, I don't like it. We should have kept Pluto as the 9th major planet and then called the things after that dwarf planets. And even one of the asteroids we called a dwarf planet after that series used to be the biggest asteroid in the asteroid belt. It's 600 miles across and it was spherical. So it was promoted to a dwarf planet. I don't like that. Keep the things we have the way they are. So I don't agree with it, but again, I don't get a say in this. So there it is. There's the solar system. And next time we're going to move out from the solar system, because we're going to find out, and we're going to find out that the solar system is not much. So that is it for now, and stay tuned.